Good evening. Or whatever it is, wherever you are. I figured to beside Nope, I could put in a few of the duo connections. I did some fix-ups on these because I discovered that we had some asymmetry with the shield load ammo. Unfortunately, there's also more asymmetry over here. Or is there? Okay, I know this part's wrong. So I was looking at this chart, and it said that this did not qualify. Now this could be a thing where it's excluded somewhere else. Wait. No, this is collage. We're gonna be looking at you a little bit. What was this? This is going to be, oh, right. Oh, no, we don't have a line for this one. And this is an activity, we haven't done the areas. Yeah, these half lines are so nice. I'm actually wondering if I should try to do something for these. Now, one possibility is we try to push the dot effect back into here. Although I don't know if I'll be able to synchronize it. But as long as we've got this open. Status immunity trait. Poseidon range trait. Shield low demo Poseidon range trait. So if that's not available, it must be excluded somewhere else. But I definitely saw that in Blizzard shot. And since it's the shot, that actually makes sense in that case. So Blizzard shot, Blizzard orb, is only Poseidon range trait. That is actually very believable. Okay, so maybe I don't have to fix that one. But once again, this is a thing where I'm going to have to look into, see if there's any other like trait features or anything. What was it? Let's see, no, D. Games, Epic, Hades, content, scripts, trait data. Oh, was the data file that covered offering? Synergy, required false. Effect immunities. Oh. They thought about making it do Styx poison. Demeter speed penalty. Oh, maybe this is if it's a one of the challenge effects. Yeah, nothing in there, but there are probably other trait scripts. Trait tray scripts? Show depth counter. So these are like actual code. And I'm not noticing a whole lot of specific trait things in here. Oh, legendary heroic hammer. Oh, relative position. Oh, keepsake can actually move. Create thread. Okay, so this is really getting into the meat of particular things. Maximum. Wow, they each get their own little thread. Check chill kill. Yeah, so I don't know what where some of these exclusions are coming from. Of course, I mean there are other things like these incompatible with. So I don't know where that is. But that might be a whole other level of invalidation. Unique god count might be another interesting thing to look into, because I've been wondering if there's a max. Of course, that's almost in the boon distribution. Oh. Well, I guess if it acted on that, that makes sense. Yeah, not seeing any specific ability names. Maybe there's a reference into these code effects at some point. Maybe they're all affecting attributes that these things are running off of. All right, we got too much stuff going on. So we did some Poseidon tweaks. I want to update the code gen so that we can run the fast version of this. So that might work, but then when we try to... Oh? Right, it just wouldn't load any of the new... Do I not have that? Do I not have layout data in there? Did I have to put an any in there? So if this only has the older types, then I could see how it would load. But we should have had those types in the parsed data. I guess this would be layout in code Elm. This should have just failed. Oh, no, it did fail. It just scrolled itself off. No, these are success. This is old stuff. Oh, pff. Okay. Why you didn't compile before? I don't know. And that is indeed where we're at. So we have area and we have polyline. Polyline is a list of points. So this is an argument list, which is... We just have map here? No, we don't have map here. Or is this just list.map? List expression with contract. Okay, so we have to do something to make this into a list. And then we have area. Area has a list of boundaries. There's a list of arguments. There's only one argument. That argument is a boundary, and then this whole thing has to get wrapped up into a list. Boundaries are actually kind of similar to this, aren't they? Except we only have arcs and lines. Right. I thought that A looked weird. Boundaries. No. Layout. Oh, I did. Now we have to know. Boundary waters. Okay, so it was A. Oh, you also have to be this. Okay, so that compiled. And then that compiled. And main program needs to get switched back. But that pokes import data. Whoa, okay. And apparently it forgot to actually compile the real file. Oh, right, winding. No archetype. I think guarantees we mapped all the fields. You're pretty much just gonna be, let's see, a construct. Is it construct with no arguments? It's a val. Now we get our fast load. Okay. So that checks off. That. Now that we have that, we have this issue with drawing, with filling shapes, and I've been putting off keeping track of all the changes we've been making here. Well, I guess I don't need the history. I need the differences. It was arcs, ended up doing some other stuff. I ended up doing some other things. So cubic curve is part of that. Dash pattern is part of something else. And maybe I could go back and rescale my stuff to avoid doing that. That's cubic curve. That's cubic curve. That was temporary debugging. Forget what I had to decode. And then dashing. So this was part of just straight up debugging. I didn't remove that little bit. This is a neat thing I might want to revisit. All right. So then and then render, we need, yeah, this. All right, and you were just debugging stuff. So now we've got a clean place where we could just reset if we need to. So was it, yeah, render, we had the little thing for loop, which, oh, because I'm not trying to fill, is that why? Right, because that was closed, it turned into a loop. So we have other things that are paths. So I probably want to go down to just Poseidon again to cut down on the number of things that are going to trip that pathway. All right, we're doing this, which we don't really need to do this anymore. Not map. Filter. Okay, that should cut down some drawing noise. Now, if we go back to area, we see nothing, but we see, oh, we're actually printing this. Shape, uniform, something. So this is going back into render. It should be all the same stuff. I think it set path to be... Oh, there's a core dot shape. Adders, events. Well, it wouldn't be events, so it would have to be adders. No, that's regular polyline, which also was not working. A3? Adder 3? Stroke none, stroke opacity, stroke width, stroke line cap, stroke line join, miter, fill none. So the raw adder data is incorrect. So we have to ask why filled is wrong. Style with fill. And I guess this must be the line type because the styled is both. There's still going to be lots of calls to this, isn't there? All right, styled is actually the public function even. Ah, shape with style and shape. So this is saying we do the constructor of that and then construct that into a collage. But filled is taking a shape. Is this shape different from core dot shape? No, shape is core dot shape. Oh. Shape is recursive? No, that's a basic collage. Okay, that's the name collision. Shape is polygon, rectangle, ellipse, circle, loop. Shape is a wrapper of shape. So path is that. So path is a collage. Oh, we get a shape that's a loop, which has the fill information. And then we redo it with basic, which basic is... How much you want to bet basic is the collage? Wait. Or is this like a default fill? Wait, these are like holes. So a basic collage can actually be typed with different types of fill, line, text type, and message. Message I sort of get because the outer stuff can use that. It's not clear how the variable fill in line would be useful. I mean, maybe if you wanted to use a custom color type or something? Anyway, so that's not used directly, it's just in the type because it gets used in the type of shape. But it looks to me like fill information only exists on shapes, and we render paths by recursion. So we simply don't have this. Wait. That's the return of adders. I guess I almost wanted to look at collage. So is adders looking at shape to get the... path, which at that point it is a path. A shape has a fill in a line. That's stroke, decode, fill. Fill none. Okay. So we have this cute little thing where we call recursion on this. But we need to use the upper thing, which is a shape of a loop, to get the fill attributes. I might have to do a full new implementation of path here just to use that one little thing. Unless we have, what, an inner version of render that can take a second collage for adders? Well, there only used to be polyline. Now there's cubic curve. I guess we can just duplicate that? Is the fastest way? I don't like the duplication. Unless we have, like, maybe we have a render path that takes, like, adder collage. What style? It's not used. Wait. Style.color, style.typeface. Oh, that's text style? Core.path style. Wait, what do we even do here? Oh, we didn't save this. It said core.path. Oh, was it saying path style? That must be the path type of collage? Basic collage path. Okay, the style is only line style, not fill. And I don't, are we even using it? Oh, maybe render was able to use it in adders. Yeah, so you're using all the line properties. Well, you're still doing all the line properties here. Fill opacity, then stroke opacity, stroke width, line cap, opacity transform, blah, 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 blah. Yeah. This is a core dot path. So you actually don't use this. Adders uses it. Case path of. So we're saying re-render with basic as blah. But really, if we get a sub-function for this, I don't think we even have to do the redo the re-render. All right. Are there any other arguments we need to be concerned with here? Your collage. We actually do need the collage. Path. Let me just grab this. Is it core? So path, I guess it might be a core dot path here. Collage.render, collage point. Yeah. And as core.path, does not have any arguments. And the collage gives us all of our arguments. We pay the original collage to that one, so it gets the fill color. And then instead of doing full recursion on this, we do that with the attributes. This is the same rendering, but a little bit more directly now. Oh, we have to redo the name. Hey, we can do filled shapes. We still have to decide if this is actually good design. It certainly, well, I think we're going to need to do this with different coloration. To support filled filled paths. Oop. And then hopefully we're done with you. So we still have some design work to do there. We still have some highlighting work to do there. But we also need to get elliptical arcs in. Which might... Let's see. So first we need data. I don't know if it's first, but... It's a tractable part of the problem. Which flips us back to here. So from our DXF, what do you show up as? So are these ellipses just with angles? Well, we're definitely cycling. Oh, that looks like a 0 to... So all ellipses have arc arguments? Or do all arcs have... We didn't have arcs in there. Yeah, single radius. Center point of major axis relative to center. Extrusion direction. Ratio of minor axis to major axis. Okay, yep. Interestingly, these are not the same numbers as for arcs. So to do an ellipse at all, it is to be potentially an arc. All right, so in order to parse that, we have to have a data structure. I guess ellipse should be a different type. Now, there's no indication that you support a winding. Now, what they actually did... Yeah, you've got an elliptic arc. So you have a center. It probably actually follows the ellipse. End point of major axis. WCS. Well, this is what we can answer from you. Ellipse 10, 20, 30. Okay. Oh, and 11. 11, 12, 31. Okay, so the 31 is technically there. 210. Extrusion direction. Okay, no extrusion. Extrusion direction. Ratio of minor axis to major axis. Of minor axis. Okay, so it's going to be a 0 to 1 because it's the minor axis. And then 0 to... So that's a full one. So this must be one of the guidelines. So we don't have a radius. I don't know. I don't have enough experience with ellipses to say what fields we really want here. Arc area, circle. Well, it's kind of arc. Just call this ellipse. Kinda yes, kinda no. Just all ellipses support arcs. I mean, in theory, all arcs could be circles. That's going to expose a bunch of things we need to deal with. I guess it's just because we're not compiling the export to code thing, but we're also not necessarily settled on it yet. Can I translate this into a standard arc? Radius would be geometry.length of the major axis. Angles would be angles, and winding would be counterclockwise. So that'll kind of stub it in. So now we can go back to layout DXF. Oh, I probably don't have ellipse entity. Parse DXF parser. It's just ellipse. We probably want to call it ellipse entity. Ellipse entity. And DXF has to define that stuff. Argument list like a train. This is going to look a little bit like an arc. Elliptic archetype. All right, center. Yes. No. So we've got the major axis on ones. We've got the ratio on 40. And then we have this on 41 and 42. Oh, and no winding. Wait. Yeah, elliptic arc type, elliptic arc. Layout. Oh, layout has to expose. All right, so we might see something wrong. Oh, still got Poseidon only. Ooh, mismatched type angle. Oh. Are you just like floats or something? Your angles. 40 is just a float, so you're actually gonna mess up my radian decoder. Yep. Oh, you're not float. You're not. You're not radians anyway. Here's the float value. Wait, I. Did you really? Did you really? No. Dionysus. Did you really flip between degrees and radians in your file format? He's only a special decoder then. Okay. Doesn't even look too terrible. I mean, I guess they weren't that far off of full circles anyway. Oh, you know what? This is probably supposed to be running down here. Yeah. What's that little segment? I don't even know what that is. Oh, maybe it had a little piece in one of these ends that got just completely messed up by this. Actually, you know what? The rotation implied by the major and minor axis might mean a different start point for the angles. Now these are actually semi-regular ellipses here. Yeah, these might be too axis aligned to get weird. These actually feel a little bit weird. So now we have the fun times. Maybe we should checkpoint that. We might change it, but oh, I guess before I can draw it, I have to do ellipse on the boon chart side. Keep wondering if I should unify these. But this is also my chance if I need to do something different from rendering versus parsing. Now, arcs had a fairly obvious representation. If this is this actually the best representation for an elliptic arc? I don't know. All right, so we had a function that we passed that to. So once we convert this into a structure, we're gonna have to, do something with it. We're just assuming we can do this. Yeah, and that's sort of, we've got this little helper function. And this is also a point where I question whether I should just be using a different internal implementation rather than trying to do this with the whole cubic curve. Well, this actually goes all the way back to curve points. So I don't even know if this is going to be a compatible implementation. This assumes we can calculate these points. So this is all radius. We can fudge this in for a moment. So really we can probably just take this stuff, this junk out. Uh-oh. Center, major axis from angle to angle. Minor radius. Yeah, minor radius sounds wrong. Did I get that wrong in layout? Yeah, yes, I did. We just never used it yet. And then we copied it. All right, now. You. Okay, center. This could be a little hairy. Well, the angles we also have to look at too. Because I think we might have to rotate, because the major axis is relative to the center. So I don't know if 2 scale is the right operation for this. Because 2 scale includes a offset, I think. Yeah, add origin. So we're going to do some of that. Okay, scale by scale factor. Rotate by God angle, and do not add origin. We're more or less running through the old code paths, just with different data. Now, what do we have to do different math-wise here? Ooh, this might be a little bit hairier. Okay, so does this have any implication about limitations on the angle. I know you're limited to 90 degrees for the circles. Limitation notes. Oh, right, this is from the actual path version. Are the radii of the ellipse semi-major and semi-minor angle from the x-axis of the current coordinate system to the x-axis of the ellipse? So that has implications about effectively the rotation implied by these. To endpoint parameterization. So they're doing all the matrix stuff. Current point on the path. Okay, from previous point. Radii of the ellipse. I don't really specify what Rx and Ry are. I'm assuming that those are coordinates. But maybe they're assuming axis aligned, so it's just the distances. And then you have the angle that specifies the rotation. Which means that it's not exactly in the same form as we have. Well, Rx cosangle and Rx sine angle, although that's a different angle. That does not use this thing. Ah, so these are times that. These are times. So I think that doing that, those aligned coordinates times the rotation is saying, okay, now we're going to put that into. Well, what are you doing with that? Because those are only single axis things. There's probably an implicit that those terms just drop out to zero because well, it's 0 times cos and 0 times anything is 0. By the rotation formula, they have the straight up angle. Now this is arbitrary point. Center to endpoint parameterization, endpoint to center. I guess we've got more of a center. Well, I am using endpoint parameterization, kind of. Cx, Cy, Rx, Ry, there's your angle. X1, Y1, X2, I2. What's FA and FS? Oh, is this like winding direction stuff? That must be defined somewhere else, because this is supposed to technically be a node. Point on elliptic arc by T is the sweep. Hmm. Yeah, this is just a very different implementation. Didn't I open up something else? Did I close it? Or did it just get rolled off? It got rolled off. So what is this in terms of? We have an angle between things. We have... Okay, so these are the... Wait, W0 equals W3 equals 1? W1 equals W2? Is that like the y coordinate? Also, this is not a rotated ellipse. So I guess that's like the effectively the y coordinate. Wait, what's B is the radius of that? A is the radius of that. So we're kind of in this axis aligned format again. And that's angle, that's angle, that's angle, angle. 2B. There's probably an A in here somewhere. It hides with the alpha. Yeah, so that's an axis aligned ellipse. Where are you getting all these parameters from? Okay, so A and B are your axis values. We have a sweep angle, which I guess if you had a start and an end, you could get that. Is this, we calculate this distance? The distance out that these are, and then do a line intersection at S? But how do we get the height of these? I guess that's just ideally somewhere, well, that's, once again, that's an axis aligned. Yeah, flag to turn if the arc spans 0, 80 or 180. Okay, so this is like the W3C algorithm stuff again. Not the stuff that we have. Axis aligned again. That's actually like a multi-point curve to do the full 180, so maybe we do have that 90-degree limit again. Take a rectangle, ABCD, axis aligned. 5-point P. Which looks like the midpoint. Just eyeballing it, they don't really define that. Oh, 8 to 1. They've got, oh, that is 0.5, and angle is 98 degrees. I don't know what the angle means here. Maybe the angle is saying, okay, we move this ellipse over that much from where a centered circle would be. Q feels like it's midpoint again. 8 to 1. Then R on DC. Okay, similar thing. S on PQ. Oh, is this a 2 to 1 ellipse or an 0.5 minor radius? There's no, I guess the units are over here. So this is a 15, and that's almost 4? So that would be 7 total. That's close to a 2 to 1 ratio. Wait, if that's the center, that's 0 to 8? And then 8 to 15? Oh no, 16, it's 8. But that's not quite 4. So it's not a 2 to 1 ratio. Exactly. But that would be an interesting theory because, you know, this stuff should, in theory, line up with that. So we do midpoint, midpoint, midpoint. Well, that would have to be... I can see how these could be related to relative height of that. I don't see why this would be anything other than the center. Oh, maybe the 98 degrees, because 98. So if you were sweeping from 0 to 98. Then S. U on ST is 8 to 1 again. So there's this 0.5 thing that keeps showing up, but is it just 0.5 period? Seems like they would only do certain ratios of ellipses. But I don't know why the left-right would change based on that. The locus is cubic Beiser. AC as major axis. So maybe it doesn't have to be axis aligned. Draw a circle with AC as diameter. Ellipse by two circle method. Well, okay, between the ellipse and Beiser curve are very small difference. But what's the formula for the Beiser curve then? This is all the graphic stuff. I guess these are supposed to be like control point. Oh, control point, control point, control point, control point, control point, control point? They don't really tell us what points we're using in the curve. But this would be kind of where it would ground out on the ellipse. We have to include the point, control point, control point, control point. So that would be one that was split into two. Oh, maybe he's referencing some other document. And we may have already hit this document. No. Maybe we hit this before. Okay, so this is Beiser curves. It's not approximating ellipse. Well, that gives me some ideas about how to do a purely geometric solution. I think that's probably similar to what this stuff is doing, but it's a very optimized version of it. Taking advantage of the fact that it's a circle. Points. That's center and the start and end points. There's probably some implicit, I don't know, like radius calculations in here. Oop. Ah, yes. Cubic Beiser curve. Oh, that's the same basic algorithm. This is only seems to be addressing circles. I guess that downloaded that PDF. Okay, so we have that rough idea. It sounds like the major to minor axis ratio is sort of relevant. So this is to given points. We are doing from angles, so we are calculating this purely by angles. I actually have to do ellipse stuff to get those points. So it sounds like well, no, I still have to do ellipse stuff. It's like I could do half of an ellipse from pure geometry. But I'm going to have to get all the tangent angles as things move. And this isn't a matter oh. Some of the stuff we were reading from the SVG was like find a point on it, and we need to find 3 points on it. And then figure out all our tangent control point stuff. Well, no, if it's a short angle, we only need 2. Wait. I calculate midpoint. Well, I might actually optimize that. But we don't even need, like, yeah, mid-angle, which depends on work angle. All right, I need more water. I'll be back in a bit. Okay.
Crashed.
So that might be why the vehicle stopped glitching out. It's still kind of doing this slow pirouette through the air.
Oh wow! And somebody died in the sky. Awesome.
All right, I've still not returned to normal gravity, although I was able to get into it.
This is worth a screenshot, isn't it?
But you know, it kind of solves that problem with money under your feet. That's what we were looking for. All right. Actually, I guess CAD wouldn't necessarily be a bad place for plotting out lines. So we kind of do need an elliptic arc. I guess some of these are actually kind of big. That would need to be split. It might have been nice to have the complete ellipse. Oh, and I want you in a different layer. Sure. So we've got the center, we've got, I don't know which end is going to count as the major axis. We have an implicit ratio to the minor axis, from which we can get that point. Elliptic arc is going to look, well, no. It looks something like... something like that. That means I need to be able to get that point and that point. And I need to be able to get the tangent at that spot, which probably is an easier thing to do in a circle. Even from the center, that's not like a straight-on line. So I can't just do the right angle. Well, stuff I've got is based on working from points. I could probably find the references to calculate points. Well, is that from an angle or from a distance around? That might be from like a distance around kind of thing, not necessarily an angle. I could probably find an intersection formula. It would be able to give me those points. We could probably find tangents. Right, so the full ellipse version of this was like we get the square, which isn't going to be quite right, but... And then we get like the halfway points to the halfway points. And we do another halfway point. And that's the whole thing. But as that goes to the center, what does that mean? Because we've got like this thing, and this thing are actually going to intersect, which, interesting, is a property of the less than 90 that our other thing had. That this line and this line will just straight up intersect. Oh, and you know what? I bet that was that kind of the midpoint is the guidelines. So given that, if we can figure out the points and the tangents and their intersection, then we back off to the midpoints, and that gives us our other two control points. Okay, here's something crazy. I think this is a parallelogram. Well, is that chance? Because that would basically just make it our relative vectors. Transpose, and we find these midpoints. Do those because that midpoint is going to be roughly similar to this midpoint, really. Anyway, I still have to transpose it up there. I'm not sure working with these would give you any benefit. So that puts us back to we're calculating point on the ellipse. Which is one of the things we had some references for. This is a wider than 90-degree angle. So this is a little bit different. Although this thing is not showing any signs of well, if those were actually parallel, they'd still be crossing. Of course, maybe if it's wide, then this would actually be crossing inside. Of course, we also have yet to see if that's correct. Wait, is this... This is already wider than 90 degrees, isn't it? 90 degrees would be there. Yeah, this isn't rotated, so it's kind of hard to follow. This is actually based on that. But I don't think these handle rotations, or they have rotation as just a parameter. X-axis rotation. Did I close down? That's EE. Oh, I guess I closed down this. Current point on path. So this implies you have a known start spot. Angle from the x-axis of the current to the x-axis of the ellipse. Okay, so these are in the form of just straight radii. What can we say about that? We could get back to that form. It could just be a little awkward. An arbitrary point. Center, dimensions of it, and then the rotation at which we have to figure out what that means. So they're assuming an axis-aligned ellipse, but I guess we could get the length of the major axis, and then the ratio of that would be this, but that it's still not necessarily the same as axis-aligned. But there is an implicit rotation in here. We could figure out the rotation of our major axis. We could get back to an angle. And then if it was angled back, then that actually would be just like x-axis and minor axis. End angle of the elliptical arc, which... Oh. Do this for 1, do this for 2. We have our 2 points. Although actually... Well, I might need to look at this again from an actually less than 90-degree case. Oh, let's see. So if it was like here, that would just be boop. And then yeah, that would not be. This is kind of accidentally parallel. Because that would be coming in here, and that would be different than this angle. So then how do we get the... Well... Oh, you're based on to focus. How do we get the focus? Perpendicular from the tangent through the contact point bisects the angle between the generator lines. Bisects the angle. Okay, sure. Yeah, this is a different form of ellipse. If a I think the images might be good. Intersects an ellipse at 0, 1, or 2 points. Through any point of an ellipse, there is a unique tangent. x1, y1. I guess I have to go find the definitions of A and B within this document. Denoted A and B. So I'm assuming that these are axis aligned, since it's referring to them as more or less singular values. X squared over A squared, Y squared over B squared. So is X always considered the major axis in standard form? X1, Y1, so that's X2, Y2, X1 over A2 times X. It has that form. That's shifted, not rotated. Perpendicular vector to whatever be the equation of any line G containing x1, y1. X1, y1 plus SUV. Oh, negative y1 times a squared. Okay, some constant for that. Does that help me get a vector? Well, I guess plus something. Into the eclipse equation and respecting. Only one point in common. If A equals B is a circle and means orthogonal. X1, Y1 plus slope times negative Y1 A squared. What that's the dimensions of the ellipse if it was axis aligned. And it seems like there's focuses again. Semi-major linear eccentricity. At the origin with width 2a and height 2b. So yes, that's I guess, assuming a greater than b. So they're assuming that's the wider direction. be a point, and that point be an equation of any line G containing x, y, x1. Be a point on the ellipse. This is the proof section. So this is the delta of the direction. So a unit vector plus the point. I guess that's, so this is the vector from that point. So we take this point, we add this. You just call slope 1, I guess. Yeah, with s equals r, so that's the entire line. We just have to rotate it by the ellipse's rotation, I guess. So that's the tangent. This is basically saying rotation. Which our vectors are already semi-rotated, but this is any point. Well, this is actually this is a vector. This is going to be 1 point. This will be another point. Can we use that? I think what I can... I can't just calculate this point and rotate it, I don't think. Equals rotation of the ellipse times major and minor of the two different rotations plus the center, so that's just, oh, so the cosine and cosine are the standard things, and then you just scale them. So the angle from the x-axis that says actually, and then just rotate it. But that form basically would say that we would need to take this, calculate the angle relative to the x-axis to get the ellipse's rotation. We get its length, we get the length of the other axis to gives us those forms. We take our angles around, which I guess we'll have to assume are from here rather than from absolute. Then we just use these ratios. And then we have to rotate by the angle when we're done. But, well, that gives us our start point and our end point, which we're actually working, mostly working from the circle version. Which I guess that doesn't count for any possibility of rotation. Your point and point. You're calculating points. So, yeah, you're the absolute rotation. So if I did a little bit of stuff in here to calculate the ellipse's rotation, and maybe to use different things for our radius here, we might be getting close. That's curve points from angles, curve points from elliptic angles. Okay, so we dummied in a radius here. So we have semi-major, semi-minor is semi-major times minor ratio. Code is broken because we don't have a radius anymore. Ellipse, angle, and this is where we have to question if maybe pre-calculating some of this stuff into some of these structures would be helpful, but actually I could almost ask if this section is always going to be doing certain calculations on ellipse, so we should just store it like that. So how do we get the angle between 2 points? Actually, do I already have a geometry operation for that? Yes. I'm not sure if the order matters. And whatever. Okay. Oh, yes, we do need to start angle and end angle, don't we? Or is that right? No, you were doing a rotation times sine and cos of those things scaled by the appropriate factors. So it's not quite that simple. Okay, center add. Yes, we see that. Geometry dot rotate from angle. This is that's just radius. This is where a simple rotate doesn't cut it. Well, is rotate just sine cos? Well, this is this thing. Which is exactly that thing. Now, well, no, it's not a like a y0 situation. Because we still have an x and a y. So what do we actually do here? So the rotation... So we can't just use rotate for this. Although, the thing we're rotating... is just an x-axis, essentially. Which means y is 0. Which means it's just radius times the... And these are two different radii. So I guess, in a sense, this could be simplified, not to actually be doing the y multiplication there. Or to make it more similar between circle and ellipse. This has a certain understandability to it, I guess. Because we're going from that point, rotating around. Although this is just going to end up being a little bit more messy. So instead of doing a rotation by that, we just we have to do a rotation for the ellipse. We have semi-major times... Oh, I probably... Let's see, do we not have this imported, maybe? Oh, and then this is a point. I don't think I have a... Yeah, I don't have like a point multiply. If that would even make any sense. Would an asymmetric scale be a shear? I guess you could do like scale x, scale y. I think most of these are aligned, but I'm not sure all of them are. And I'm not sure which direction we were mostly stretching the ellipses out in. So this is a little bit squat. Ellipse. Ratio. Center major point, yeah, XY. So that is... Oh, okay. I guess you could maybe you could enter this. No, it's calculated these. Are those in the data file? It's treating that kind of like major data. No, we'd have to have 2 points for everything. It doesn't have that much data. Because it's just showing that to you. Yes, I think some of these might be... Yeah, that one looks like it's probably a little bit rotated. Which explains what some of the ones that feel a little bit off. So I might want to turn this around to like, and then add center. Because we need to take this point, we need to rotate it, and then we need to add center. Now, will this still work with curve points? That was technically the formula for a circle. Actually, and these are just points, so maybe not. And we'll get some of our positions a little bit better, but we might still not have quite the right ratios. Because still going to be trying to figure out a circle from that. Oh, we still got a radius. Ah, midpoint. Oh, so you're gonna look a lot like this. What were you? Midpoint. Okay. Some of those curves look a little wonky, and looks like we're substantially upside down. Yeah. So that fixes some of the major displacements, I think. But that function is not set up to handle ellipses. Yeah, that's supposed to go over to here. Which has me questioning a lot of things, since we were working from endpoints. These have a couple little endpoints. Yeah, because those had to, the angles changed up here. So how do I handle an ellipse differently from a circle? Maybe you have to consider the major and minor axes. This is such a nicely reduced formula. It's kind of hard to say what's going on. This is from a center and a point. Where's my scratch pad? Oop. Oh, right, because an arc. So I actually need to start here to here. So we've got a point and a point and a center. Oh, does not have window mode. Okay, so AX and AY. Oh, so these are absolute points. So this is just vectors. Is it possible I'm passing it in that format? You know what? I'm adding center. And then my curve points is subtracting center. So there's some possible room for optimization here. We could assume that, and then, well, I guess I have to go through and add center to all of these. So I guess I'm still using the absolute values here. So we're getting these as vectors. A squared plus y squared. So that's maybe that is it's distance, but we're keeping it around a squared because we're just going to use that again as squared. And Q2, that's A. Is Q1 plus A times B and AY times BY. I mean, it's been working. Did we copy that right? Okay. 4/3 square root. Okay, yeah, so we're keeping these square, then we're doing a square root after doing some other stuff. So these are like squared and squared and times each other and then times each other, which is including that one, times 2 square root of, oh, and then there's AX, BY, AY, BX. And is K2 like a factor? That like 0.5 we were seeing some of the ellipse things? And then here's the center back to all of our points. X2, Y2. Oh, because we're doing these. But in every case that I'm using this, I think I'm adding center before sending it through here anyway. So we could maybe be just going through and adding center to all the points after we're done. And then ratio times, so x2 is AA. Oh, AX, AY, AX. BX plus factor times BY. Huh. Since I don't understand the origins of this, it's not clear where I would put the ratios in. I guess one obvious way we would put them in there. Well, these things are kind of dealing with radius. So I'm not sure how much that comes into this. So that's the factor of where to put the control points. If I go back to my tangents, I could just calculate the... Well, I guess I'd still need that factor. But is that just effectively like the midpoint of the two lines? Well, they're using 4/3 here. Somehow we're getting tangents out of this. Because the control points have to be long tangents, right? X2, which is closer to X1. AX is derived from X1. Is AX plus AY. K2 times AX. Oh, it's inverting the... So if an xy vector gets a perpendicular vector just by inverting coordinates, right? Which is a that's using a property of circles. That's not necessarily a property of ellipses. So we've got this factor, which we just kind of grabbed. And I think this is supposed to be the perpendicular, which we could get from the tangent. But what about that factor now? Maybe if we could understand that from the source material? All right, this is kind of trying to get a factor that is scaled relative to the size of the circle. Would that be roughly equal to semi-major and semi? Well, no, that's just the radius. They would have just used radius if radius was the thing. I'm especially bothered by the fact that, like, we're not even meeting up. Because I would expect the curves to be a little wonky. But this actually feels like our endpoints aren't being done right. Can I change? What do I do with you? Join curve points, join curve points. Arc from angles. Is cubic curve. Wait, that's area. Elliptic arc. Okay, so the elliptic arc is giving us a curve. Cubic curve is, okay, that's our internal thing. So elliptic arc from angles is a cubic curve. If we were to make that just a path, yeah, so that's where our wonky control points are. But we still have these mismatched join points, which means we're not even doing that right. It might be helpful to unrotate things here. Oh. Okay, so we're just applying the rotation wrong, for one thing. That messed everything up. What did we do for that? We flipped this around. Ooh, okay, that's disconcerting. Okay, so yeah, this is part of the mistake. But these points are lining up a lot better. That's nice. And that should be at most 180 degrees. So what do we have to do? Actually, we're not considering God angle at all, are we? Oh, no, we added God angle. Well, that means this is wrong if it's affected by rotation. What do we got going on here? We rotated. I wonder if that means that from angle and to angle are not ellipse relative? Oh wait, I never did that. Maybe I thought that I'd be doing it on the other end. Elise angle. Now we know that things were messed up when we rotated. Does that mean mid-angle is going to have to be offset too? I might have to then work from those. I mean, the sweep will be the same, but in absolute terms, this would probably be start angle. Okay, so now you're wonked. And you're a small one, so you're not going to be affected by mid. So that makes me think that maybe these aren't. Well, no, when the whole thing was rotated, it was weird. Also, I'm not parsing anything right now. But have I actually generated data for this? I guess I skipped that step. Oh, yep, elliptic arc on encode elm. Oh, maybe I was waiting to see if it changed, but we're just freeloading a lot right now. So you are center. Major axis. Major axis. Point. You are... Well, we do have that. Minor ratio. At minor ratio as just a float. All right, we can reload faster. All right, so I think that must be this chunk. So attempting to add the ellipse angle appears to mess that up. But things were also messed up when we rotated things. Oh, we don't need this anymore. All kinds of messed up. Did we rotate the wrong way? No, that's not it. That doesn't seem like it would be good. But it's a little bit better? It's still not quite right. Okay, so the center moved. That would have been scaled. Major axis is supposed to be relative to center. Okay, that was really bad. That was amazingly bad. How is that mostly right? And that's just an absolute disaster. Do we have like mixed units or something? Our other one was scale, then rotate. I wonder if we're doing our ellipse angle calculations in absolute space. Because then that would mean we'd want to be doing that relative to the original origin? But that wouldn't explain why things are super messed up. Because it's just getting the ellipse angle relative to a different reference point. Unless that's doing weird things to... how we calculate the downstream angles. So I guess part of this is that it's simply not documented whether those angles are relative to the ellipse or relative to absolute. That gets us subjectively worse results. But rotating this also gets us subjectively worse results because our points aren't meeting up. Oh. Is that messing up these calculations? We're assuming, we're just kind of calling this x-axis and this y-axis, so to speak. Counting on a rotation, which we rotate the entire thing to put us back. This doesn't have access to God angle. Just for reference. You can look what ellipse angle turns into. Oh, we have 3 zeros. So there are a bunch of aligned ones. There's one almost aligned, which probably should be aligned. Really. And then 1/2 pi 90-degree turn. Okay, yes, there's one that's in another orientation, which is that one thing that keeps going out of whack. Wait, but we've rotated you by a non-pi nice number. Oh, did we say we don't rotate the major axis? Yeah. And somehow things end up in more or less the right place. How can that be? Well, almost the right place, but not really the right place is the frustrating bit. I guess those circles are mostly at 0 of the local coordinate system? But it seems like you'd have to rotate that. And yet there it is. Oh. My arcs did this. If these are ellipse relative angles, wait, how is this having the exact same effect? I mean, I guess we're recalculating some ellipse angle from stuff. I've been playing with adding and removing it. That seems like it's rotated the wrong way. I guess it's the fact that we're... Okay, ellipse angle, blah, 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 blah. Oh, it's like the same ellipse angles. What? Okay, basically 0. 0.06. -55. Actually 0. Negative 0.02. Okay, 0.02, 0.55. Okay, I sort of get that. Well, that one side flipped and that one didn't. That we're near n-axis there, but it's the y-axis, and I thought we were working with x-axis stuff. And somehow... Oop. Oh, you know what? My angle between can probably only get... It's like the absolute acute angle or something. It's not going to be in a particular direction, which is what we're looking for. Do we do the same thing? This might have been where I was trying to do some similar things, or trying to do some similar things, and I tried this out and thought about it, and I think we said oops. So how do I get the absolute angle between something? We apparently just did we did something else here. There's our other arc thing. Maybe I was trying to do angle stuff and it was like, oh, I guess we can't do that. How do we get the absolute angle of something? Not angle between. Okay, that's the length. Oh, V. No, I need to know how to do it. That's angle between. I don't just need the small angle. Oh, wait. Like there's our parallel. And the length of cross. Axis. These are at absolute values. Is this what I'm using? ACOs. Maybe ATAN? That's a distance. Wait. Oh, absolute value. Okay, yes. Between two vectors, I just happen to be magnetic field. Absolute value of the side taken to find theta. Is this really not a problem anyone else has? Direction and angle. It's a video lesson. Wait, this must just be polar coordinates. Right, because it has to be an absolute angle. Okay, R equals, oh, it is A10. Okay. Is this a thing we want at geometry? It's kind of one function. Oh, this is A10 too. Do we have? Do we has? Find the angle in radians to an xy coordinate, but in a way that is rarely useful in programming. You probably want A10 too instead. We do not get angles that go in a full circle. A tan y over x. But this is float, which means... Actually, this... No, we do multiple things with major axis. Okay, so now we might be able to say that our choice of rotation direction makes a difference. Maybe that is that angle backwards, maybe? Fine. Do it the hard way. Nope, that's still just, well, now we have questions about which of these we should be adjusting. Okay, that looks like trash. We were kind of getting better results before, weirdly enough. That's, oh my god, what the heck? What the heck? Oh, maybe I need to wrap these now. Yeah, could be. Of course, I've got a thing called angle. No, you're the wrong one. See, we're just mod angle, work angle. By itself should just work. And then you guys, didn't really help much. Of course, I guess if we end up with a negative, are we ending with a negative? We can get negatives. Okay, so this is still less than pi, so it must be that it's taking the nearest direction. If odd angle greater than pi, so we're actually trying to shrink u. I guess we can keep on using mod angle and also have it fix direction issues. Yeah. Turn off the camera. If a greater than tau, well, then it's not going to be less than 0. Is this tau or pi? Tau. And then we want to use that to fix u. Still looks like trash. No, I can't just comment this out. Well, that's a more recognizable shape. Oh my gosh, what the heck is this? We weirdly got some of the best results tweaking the angles. My big problem is I don't know if these are supposed to be... Well, we had that one segment that was like kind of crazy. If we didn't do something. Okay, well that's wrong at 0, so there's your first problem. Okay, we're not rotating by an angle. So that means anything we're doing in here is objectively wrong. That seems like it has a 90-degree spin on it. And what do you know? Most of our ellipse angles are about 90 degrees. Some of them look right-ish. Oh, that didn't even make a difference. Am I actually using these? Yeah, start angle, end angle. I might not be using these in work angle and company. Okay, your difference doesn't matter. That might matter. Oh, actually, that's what that is. Now we're mostly upside down. Well, those are the big ones. The big ones got split, which suggests that the midpoint went the wrong way. How does that work? No, actually, if that flips this down here, then these things are backwards too. And just like in very, very wrong positions. All right, so these are actually useless because we're not doing that right now. How did we have stuff that was almost right before? Well, we were doing a slightly different angle calculation, but I guess that would be right for most of the segments because it would just end up being 0. So what is A10 relative to then? Because you might be in a different coordinate system. One, 1, depends on your coordinate system, 45 degrees. 1, -1. I don't do 0, 0. Well, 1, 0. We can do that though. Hey, what do you know? What the heck do you consider 0 then? Okay, you consider 0 to be the y-axis. The data I'm importing considers it to be the x-axis. Right. This is going to be minus, isn't it? Actually, is this something I should fix here? And we've got to figure out what our rotation direction is, but we are converting from a layout thing to the thing we want to display. Oh, no, this actually feels like an ATAN thing. Oop. Right, it's all technically the same file. Is actually the thing that's messing me up here. All right, we went messing with our midpoint. Although, that's what it probably should be. No, that's pi. Oh, no, I ended through that. Okay. The major elements are roughly the right space. Where is this lost child? That looks like you, if I had to guess. Which is all kinds of flipped. Let's see, I was counting that to fix some stuff, wasn't I? Okay, so it's not that. Assuming we compiled. I might need to try and find some way to figure out what that is. So we ended at 0, so that is the scope of all the things. That's 0 with some fudge, which I guess we're just picking up some garbage from the math here. There has to be something peculiar about that one ellipse. Oh, you know what? That must be the one that is 0, 0, 0, very close to 0. So this has to be you. This is before we put mod angle back, right? Oh. Effectively 0. That was negative, so we turned it around. This is kind of 0, but we wrapped around. I wonder if that's the issue. All right, so what are you in raw? You're a very, very small negative angle, so So probably we're getting this big turn value here. Although it's a quarter turn. Well, if it was here, or should be there, that should be about a pi rotation. Oh, but then what are the angles that are associated with that thing? Now, I don't know that Elm guarantees execution order. It's just a big soup of values. So these are, let's look, it's from to ellipse angle. And we've not modified these in processing at all. Well, no, we modified U. That's why I'm using ellipse angle for anything right now. That's from 2. Okay, so negative. All right, so the raw values are 4, 5. We can kind of just verify this. Yeah, that looks like a 4, 5. Weird, those are slightly different. And indeed, we have a y major axis. Uh, 4, 5, so whoop, bleep, bleep. Okay. Then we have from 4 to 6. That must be U. Okay, a little piece. 2 to 3. Sounds like that. Oh no, no, this is 2 to 3, 3 to 6. So what's going on with you? These do feel like if this is 4 to 4 to 5. Yeah, if it was absolute, this would be like 0. So that has to be ellipse relative. Well, now we got a negative in there, which might not be good. That's not right. Also not right. Are we doing anything else with ellipse angle? Oh, we are doing ellipse angle stuff. So that kind of figures in. Huh. Most of these are 0. Okay, so the sign is also wrong. Wait, oh, we were leaving this, but that is actually just plain flipped. Which one are you? Now this is the post-processed. Ellipse angle 1.5. Wait. Weren't we getting like negative 1.5 or something? Can't do that, huh? Did they get rearranged? Right, we're still doing atan. So atan is calculating that as 0, which is not right. And these is 1.5. And then that as positive. Okay, that is the right place. Oh, but you're negative. We did minus. Okay, so all of those were plus. We subtracted to get them back to 0. You were at 0. So you got made negative, and then that made it positive. So equivalently, this would be negative a plus. So I guess this, could this be a geometry thing? To also apply this fix up. Now that makes the geometry assume the coordinate system that we're using for stuff here. Although I guess I'm kind of making geometry assume like rotation direction and things. It's kind of the graphics packages that are always starting at x-axis as the starting point of our angles, which we've just continued to kind of use. I guess we kind of want to do the fix up. So we're modifying this. Well, this is going to be originally 0 pi in either direction. We're going to rotate it, which could make things a little bit weird. Flip the sign. And then we could very, very well have negative values. Now, mod angle could conceivably be a geometry thing. Because that doesn't have any peculiarities tied to it. It's just positive and, well, we're only bounding it once. We're not accounting for multiple rotations. Angle of major axis. Don't need fix up. Mod angle is in geometry. Geometry doesn't have tau. Of course, we went and exported everything from here. Oh, but it was geometry dot, so. Okay. So in a reference position, things don't look like an absolute disaster. The unevenness of these lines is pretty bad. But our basic points are in the right place. Okay, we are not handling rotation at all. It feels like it might have moved down a little bit. Actually, some of them rotated. Probably because we moved the centers. So now we have questions like, do we do this? We might do that. Yeah. So where did we swap this for path? Okay, so assuming circles is still leaving us some slightly wonky results. We don't have points that are actually on circles, so it's just kind of confused. That was still pretty hard fought, though. All right, so we're kind of calculating these in relative coordinates and then leaving it up to this final rotate center to put things in position. That's collage. So we are outsourcing to curve points, which is doing a bunch of stuff we barely understand. It's probably like an optimized version of some geometric operations, and I think the thing we did referenced a paper. We might be able to kind of back into what they're doing. I don't know if that'll tell us anything about ellipses. Circular arcs and vice versa. Okay, so that is a definitely non-circular curve, but it is the algorithm, which is kind of the thing we saw in that other ellipse thing. I wonder if this will explain some of the choice of points defined by 4 points and 2 control points. The outline of the curve itself. Parameter t is tangent to the segment of line at the start and at the end. One circular arc subdivided by the curve into 2 sections, approximate the curve by its control polygon. Corresponding parameter intervals. From the original control points, we obtain new control points. Okay, so this is the process of finding where your midpoint control point is. I've been doing it by calculating an angle, but I mean, we can do angle things. It's the angle of the ellipse. It basically makes the midpoint the same process as the other things. I don't think we have a particular problem with that part. So that's taking care. Oh, the subdivision, and we're getting our new control points along the way. Oh, and this hull is the control points. But this assumes we can calculate the curve parameters for the larger curve. Converting a circular arc into a Beiser arc. It is impossible to draw an absolutely exact circle with one curve. We can approximate a unit quarter of a circle by a cubic Beiser curve with an error of blah blah. Widely described in books for curves and surfaces. So, okay, so since it's that, okay, this is more of an arbitrary curve, not this nice perfectly aligned thing, which is a very, very easy case. Less than 90 degrees in radius r. The clockwise arc. Well, this is one that's centered, so that makes it a little bit easier, maybe. Centered along the positive x-axis. But once again, vectors on a circle, the tangent is super easy to calculate. The variation of tangent magnitude L is within the domain. Calculate the coordinates of the control point. So this is kind of what that code we got. Yep, and there it is. C is K on that graph. K is not on that diagram. I might need to back up to figure out where they describe. Oh, well. Okay, here we go. In this case, d equals k. They ever like define can be expressed as r times k, where k is a constant, often called the magic number. And yet, we have something that calculated our magic number. Okay, here's the formula we saw, more or less. And here's K2, which is what we saw in the code we copied. And okay, so here's this stuff. Directly does not participate in the calculation of the magic number could be as follows. Minor kind of approach. Least error at 3 locations. Arbitrarily positioned operations of rotation scaling transformation are used. Yeah, this is a direct translation of this. Control points are absolute coordinates and not any rotations transformations are already needed. Counterclockwise arc, the value of K2 is positive. Approximation of Bezier curve by circular arcs. Yeah, I don't think that helps us. So they just kind of describe this as the approach. They don't really say why or how they derived this. And I don't know if they really just, unless their K is going back to here. All right, so we could get tangents to an ellipse. But how long are they? And can we associate? I mean, this is exactly what we've got. I'm missing a minus Q. Oh, no, there's the minus Q2. Maybe it'd be slightly easier to read in that notation, but doesn't really explain why. We might conjecture that inverting the x and the y is a cheap perpendicular. Oh, no, actually, it's y1 and x1, not like the a, b vector form. So the inverse, so it's x1, that's basically inverted, which is, what, a flip about the 45-degree axis-ish? That's almost there. It would be on the unit circle. So I'm not sure that that would actually be on... That'd be on that same line. Actually, I'm not even sure that is that a 45-degree flip? About that. Oh, and what are we doing with signs? Minus, plus, plus, plus. Okay, so this is a little bit of that rotation sign stuff too, maybe. So they're doing specific signs. So maybe that's kind of implied what that would be to get the perpendicular. And then you're multiplying both of those x and y by a singular factor. Well, I guess if that nets up being like this direction with the same magnitude and then we're cutting it back. But I don't know if a single K2 factor would work for an ellipse. What can we say about an ellipse? Like if this kind of thing was super squished down, then it wouldn't be a simple flip, but we could calculate the tangent. I guess I'm not sure how the length would be affected. Or would the length be affected differently for different points? Let's see, over large. That's one of our axes, which makes things maybe a little bit too easy. Of course, it ends up being a very, very small little thing, so we've got whatever that tangent is. And whatever that tangent is. So actually we've got a very, very... And then somewhere in here, we've got our 2 control points. It feels like that's going to be a different ratio. And I don't know if I have good tools to describe how it's going to be different. So if we took the circle K2 as an approximation, used an elliptical tangent formula, because at this point we've already calculated the points, and we can do point on an ellipse. Oh. Tangent going which direction? Oh wait, is that is that an answer or is that related questions? No, 2 answers. Related answer, related answer, related answer. I only see 1 answer. I guess it's the answer. But this is that like subdivision thing and angles I don't understand. I guess we do get some control points out of this process, but we're using these easy perpendiculars. Here's using a 0.5. This is back, collecting with cubic Beiser curves, but this is going back to the web stuff. This is approximating with cubic Beiser curves. Endpoint syntax, which is not what we have. Center parameterization, which is not what we have. Well, angle from x-axis to x-axis of ellipse. We kind of have radii. Difference, well, okay, we sort of have that. Endpoint to center parameterization, taking floating point arguments. There are a few helpers needed. Ellipse parametric equation. Derivative of ellipse parametric equation. Determine angle between two vectors. Well, we can do that. Takes a step angle to determine the number of curves to use in the approximation. Well, okay, so we've been super simplifying that. Namely pi divided by 4. Up to 4 bias occurs, we use to construct an elliptical arc. Oh, a smaller step angle. Okay, so you just use that much angle sweep and then have a leftover. Step angles to determine the value for... Okay, so we have an angle to... Okay, implementation? Using a pre-computed value for A and to only draw the remainder if it exists. Okay, so for a quarter turn, it's that. I only have to compute A once. Okay. Okay, so here's there actually is something hiding here. But this is relying on some subfunctions. I don't actually see them called. Maybe they're... Oh, wait. E prime, and angle? Are those hidden in mathematical notation? E prime. I don't see angle. It's probably in here somewhere. Number of segments. We're going to do that a little bit differently. Oh, but he's using his pre-computed A. And I guess this is... Oh, wait, is this... This is called arc. But it's call cubic. Okay, cubic with points, cubic with points. Cubic with points. Oh, so it's pre-computing a bunch of stuff for this quarter turn case. And then doing the general case here. This is a bunch of math notation. I don't know if I could copy it into my program easily. To just grab a reference, because it's starting to get a little bit late. I know this would be hard, and it's expected to be quite this much trouble. Well, we had a lot of diversions with the rotation issues, and what's absolute and what's relative. But this looks like it's basically what we need. I guess we just put this in here. Okay, we did that. We did that. We have to draw them now. Ooh. Right, and we have to implement subfunctions. So ellipse, derivative of ellipse. Maybe once I get that into code, I can make better sense of it and put it into geometry or something. So he's bolding these functions. Maybe angle is used. Oh, angle is used up here. Okay, so he's defining functions, but we're not using this in the thing we're doing here. Okay, so we're updating t as we go. T equals t plus, but this is going back to... Is delta like the leftover now? If n not equal to segments for n times, segments... Oh, absolute... Oh, this is probably like floor for that division. Step is t. Okay, so here's our t. Minus pi? Oh, because we added here, so steps back to where we were? So our starter position plus our delta. So this is like the entire thing. It's not clear where he does. Oh, because we keep updating P1 and walking it across. So we've initially we sort of have an implicit start point, and then we're doing this thing. Sign step. It's not clear where we're getting the remaining angle to do from. There's this center thing. Oh, this is the two forms. So this is from that form. This is going to center form. Radius center. Oh, R, RX, RY, RR. So I guess R is just implicitly a two-part thing. Oh, so T is the part passed. So it goes back to base T. O1 plus delta. I thought delta was like the total distance you had to go. Hmm. I don't know why these are set equal. Unless it just means they're calculated the same way, but why would they be equal to 1? Unless those are angle rotations? It seems like it only solves for a very limited case of a very symmetric set. Well, S is the distance. That's kind of interesting. That's sort of our A factor, or our K factor. This is the amount of lift, but that's kind of the same thing as this? Or is that used? That's not used here. That doesn't use S. Oh, and you see, this is well, this is in terms of B and A. But this is in such a axis-aligned position that I'm not sure I can trust this to be generic. I'm not sure what this is actually doing. Transform center. Oh, a point on an elliptic arc. Well, we think we kind of got that. This is the conversions. I guess they're suggesting that if you have a big curve, you break it down into pieces and sort of do each section. This is the same document. There's a reference from before. There's this, which just kind of ends up handing it to you. There's the tangent. We think we've just got the code now. That's an easy to find document. Now I'd say this is something I might try to do offline, but I've also got tons of design issues to deal with offline. We've got lots of duo lines to put in. We're discovering lots of issues with the current layouts, which we'll then have to come back and think about. I mean, well, this is at least suggestive of the shape. So normally this would be I schedule programming time mostly in the mornings. I might want to continue working on it in the evenings, depending how things go. But for now, that's it. Thanks to the support from the subscribers. And good night.